Okay. Okay, let me introduce myself first of all. My name is Jeff Spiller. I'm with Hewlett-Packard. A little bit about my own background. I took the tandem compact computers HP path. So that's how I ended up there. So technically, I've been with HP for almost 33 years. For about the last 21 years, I've been doing data warehousing, business intelligence, so forth and so on. Even though I'm the tech lead for the product right now for the parallel data warehouse appliance, we're also getting very involved with Hadoop. We have an 18-node Hadoop cluster in our lab, so we're starting to work with that with HD Insight. I primarily specialize in things like performance tuning, capacity planning, database design, architectures, so forth and so on. So that's pretty much me in a nutshell from an HP point of view. What I'm going to be talking about today is for about the first 10-15 minutes, I'm going to be talking about what big data is, because it's an overused buzzword. I'll give you my interpretation of it. I think I've been to like 2 or 3 sessions here that talked about big data, and everybody else has a different spin on it. Very close, but everyone else has a different spin on it. I've also heard that Gartner Group was trying to get rid of the term because it's so not defined, per se. So we'll talk about that a little bit. I'm going to be spending about 10 minutes talking about user profiles. And the reason why I want to talk about that is because when you talk, I'm a performance person. So since I'm a performance guy, I think it's important to understand how the users actually use the machine, because it's really the workload that affects how much hardware you need to do the job. Almost every vendor out there says, well, we could support, 6 terabytes, 100 terabytes, 5 petabytes, 6 petabytes, whatever it happens to be. Well, that's a nice number, but if you can't meet your service level agreements, response times, throughput, so forth, it's pointless. So yeah, the amount of dollars per terabyte is a nice metric to deal with, but you also have to deal with end-user response time. So we're going to be touching upon that as well as obviously the PDW hardware architecture. So to start with, we're going to be talking about what is business intelligence, what's big data, what it's all about. In terms of what big data is, what we have on the slide over here is traditionally if you've been in the data warehousing and business intelligence market, you know that we have structured data. We've been doing this for the last 20 years at least, where we take the OLTP, the transaction processing data, could be CRM systems, ERP systems, so forth and so on, call detail records, and take all those different kinds of transactions, whether it be credit card transactions, stock transactions, and are those considered big data? Well, the answer is, well, I don't know. I guess if you're the New York Stock Exchange, it might be. If you're AT&T, yeah, it might be with your call detail record, so forth and so on. So that might be one type of big data. It would be the structured big data, but we've been doing this stuff for over the last 20 years, and we have a relatively good handle on how to deal with it. The next type of information, which is a lot more recent, and where things like Hadoop and so forth and so on might be defining as quote-unquote big data, has to do with semi-structured data. Those semi-structured things are things like XML file, RSS feeds, spreadsheets, flat files that have a known record format, or even web logs. So yeah, there is some structure to the data that you might want to analyze, but everything's a little bit different. So it's sort of easier to analyze than something that might be perceived as unstructured data. Unstructured data, you never know what you're going to find. You might find email, text, SMS file, audio, video. Sometimes, let's say in the Hadoop environment, you might require semantic analysis, or maybe you have a video or a picture. How do you put that into a data warehouse or images? Well, you might have to look at the metadata associated with it and draw inferences from that. So about 80% of today's data volume might be that unstructured data. Another huge percentage is semi-structured, and the structured is relatively low in terms of volume. So that sort of qualifies what I would mean by big data. It's really a combination of all three. As far as you guys are concerned, big data probably varies depending upon each customer out there. So I hate to use that word as a very generic term. What I'd much rather people start doing is take their big data term, throw it out the window, and start saying, am I dealing with structured data? If that's structured data, you might be dealing with PDW or fast track. If it's semi-structured data or unstructured data, well, now we're probably talking about Hadoop and HD Insight from Microsoft's point of view. And that could be HD Insight Azure or the standalone version when that gets released. In either case, all three scenarios on the bottom of the slide over there, all three of them, that is dealing with all the back-end systems. So we just briefly touched upon the back-end systems. What I wanted to do is just talk about the front-end systems for a second. Now, the front end is where the users come into play. And remember earlier I mentioned that it's important to understand, are you meeting your service level agreements? Yeah, I could store tons of data. I could fit, 10 terabytes on my home laptop. That's not a big deal. So the real big deal is maintaining the user service level agreements, response time, throughput, so forth and so on. But what kind of tools do these users use? Well, there's different types of users. We have executive users, power users, business analysts, and casual users. You're going to find out that your executives tend to like dashboards. They like the pretty buttons and the traffic lights and the little speed dials, so forth and so on. They also use OLAP tools on occasion. Then you have your power users. They might do data mining, advanced analytics, it's sometimes called over here. Your business analysts typically use your OLAP queries, which is really SQL statements. And then your casual users also use OLAP in reporting. You'll notice one thing on this slide. There's a common thread. Almost every tier uses OLAP. Those OLAP things are primarily deal with the structured data. So you might take your unstructured, put it into a structured format, and then you use your OLAP query tools across the entire spectrum to handle that. So what's the moral of the story? The moral of the story is you want to make sure whatever engine you're using in the database can handle OLAP types of queries pretty well, because it's going to be very useful throughout your entire organization. Executive dashboards, we sort of touched upon this before. What's it used for? Those are the pretty dials, windows, traffic lights, speed dials, and they deal with high-level metrics in terms of what's going on, and the executive just cares about strategic and tactical decisions. If he sees a red light, he's going to dig deeper. If he sees a green light rather, he's probably going to keep on going and completely ignore it. Then at the lower end of the spectrum, we have something called the casual users. The casual users, typically what they do is they care about day-to-day operations. They care about, what actually happened. They tend to qualify their queries by what's called highly qualified in time range. For example, your casual users say, I want to know what sales looked like yesterday, so forth and so on. Or if you're looking at call detail records in a telephone company, they want to qualify that, what happened this hour, this particular day. Or they may look at trends over time, and if they do it, it's very specific information. Those guys usually use reporting services. They may use roll-up tubes, OLAP cubes, PowerPoint, Excel, and those kinds of tools are what those guys deal with. Come on. The business analyst users, even though the casual users cared about what happened, the business analysts care about why did it happen. So what's important to think about business analysts is that they form a hypothesis. They might notice trends in the business. And they say, I wonder why when we put the sale on in the department store or the supermarket, why things didn't sell the way that we thought they would. And they start putting queries against the database, form a hypothesis, and they look for the data to basically confirm what their theory was. And again, they use Excel, PowerPoint, dashboards, so forth and so on in order to do that. Then you have your power users over here. The power users, these are the guys who, they look at things a little bit backwards. Remember on the previous slide? I said these business analysts, they care about what happened, but they form a hypothesis first. They think that sales didn't work as successfully as they thought because of a certain reason, and look for data to back that up. On the other hand, the power users does things a little bit backwards. They have the data create a theory for them. And that's where the advanced analytics or the data mining algorithms come into play. If you're using the various data mining algorithms, they might plot these pretty little charts and patterns. And by looking at those, you say, there's something very unusual happening in terms of how my customers, their buying patterns, and then they would act upon it. So they don't necessarily form a theory first. They actually look at the data and let the data trigger other thoughts. Different kinds of applications for these power users. And this is where most of the emphasis in the industry is right now. A lot of people in this business are not so much concentrating on OLAP. They're looking at the advanced analytics and data mining. These power users might be doing things like basket analysis, do cross-selling. They care about customer retention. Telephone companies are big with that, credit card companies, so forth and so on. Fraud detection, the credit card guys. If you're a retailer, you might care about items returned in the store. People maybe, steal something and then return it, or buy 2 items and return one of the other ones, so forth and so on. So that would be fraud detection. Collection analytics, let's say, you're a collector for a bank or a company. Underwriting if you're an insurance company. Health and resources. And social graphing is interesting because that crosses the line across everybody. Because almost everybody, they have social interactions and that might affect their buying patterns. What kind of models, you've heard these terms about advanced analytics, data mining, what kind of models do people use in those systems? There's 3 general categories in case you haven't heard of them. One category these power users use are called descriptive models. What descriptive models do is they categorize people. They basically try to figure out, I hate to use the word stereotyping, but what they do is they take different people of different backgrounds, probably socioeconomic, maybe geographical, and figure out what their buying patterns are going to be. And by categorizing people, they try to predict what their buying patterns are and how to influence them to buy more product usually. Predictive models are trying to predict human behavior. And of course, decision models, they figure out a ripple effect. If something happens, like a hurricane happens, what's going to be the item that sells most frequently? So they're going to figure out, person buys product A, will they buy product B? And that gives the ripple effect kind of transaction. Another buzzword, which you should be aware of in the industry, people are starting to use, they're trying to say, oh, we have real-time analytics. Well, it sort of raises the question, what does real-time actually mean? Well, real-time, do you really need real-time analytics, first of all? For example, do you really care, if you look at these graphs over here, these cluster analysis graphs or these time series analysis graphs, if you have data up to the second or up to the last minute, when you're dealing with terabytes of data, is that really important? Do you really care? 90% of the time or 99% of the time, probably not. Now, you might care if, let's say, you're using a data warehouse for sensor analysis, or you're analyzing it to find out if your nuclear power plant is going to go ballistic. Then you probably want real-time data. But for the most part, if you're doing retail applications, so forth and so on, or banking or brokerage, in those particular cases, you probably don't need data up to the last minute. But it's something to bear in mind, because that's a buzzword that's coming into the industry. Do you really need real-time analytics? The answer is maybe. Just think about it. As far as how do you get these tools, how hard are they to use? Do you really need to be a quote-unquote rocket scientist? What Microsoft has done is they've taken a lot of the most commonly used data mining algorithms, or advanced analytics as the case may be, and they've put it into Excel. So if you combine Excel and Microsoft OLAP cubes, you could actually, there was actually a demonstration that I went to yesterday, I talked about this in great detail, about how you could use the Excel spreadsheet to be able to do data mining. So you don't have to do OLAP queries all the time. Your end users, those power users, could use Excel in a very cheap way to actually generate these kind of data mining algorithms and make these kinds of decisions. So it's a free plugin. You need OLAP cubes, and it's very low cost. On the other hand, what other people are doing is they're saying, you know what, I want to analyze data against massive quantities of information. Excel may or may not be as powerful enough for you. If it's not, you could then take, let's say, a fast-track database or a PDW data warehouse, extract samples of information or large quantities of information, put them on another tier, and then you can use things like SAS or Vertica or other things within database analytics, and now you can do your heavy-duty number crunching. One of the things I want to point out to you, there's some vendors out there, what they do is they say, oh, we could do in-database analytics and do OLAP on the same platform. The answer is, yes, maybe you could do that. But bear in mind, if you look at the data mining algorithms, those are pretty complicated mathematical formulas. They're crunching through massive amounts of information. Yes, you might be able to do them in the database, but what are those CPUs doing? What's the memory doing? If you're trying to burn a lot of resources by doing these data mining algorithms in the database, that doesn't leave a lot of cycles available for your users that are doing OLAP queries, for those users doing reports. So be careful if you're looking at various vendors that say, oh, we could do both in database analytics as well as OLAP queries. Yes, you could do that, but if your workload forces a lot of contention against each other, you might end up with performance problems. So it's just, again, food for thought and something to think about. It may be good, but it just depends upon your own workload and your own environment. Now, when it comes time to size these things, the easiest way to do it is saying, well, how many terabytes is my database? And you just get that many number of disks. However, there's a whole host of other issues that come into play. I was trying to, in the first like 5-10 minutes, is talk to you about different kinds of workload profiles. If you look at the data itself, you look at the queries, categorize them. Are we doing simple, medium, complex, very complex queries? Are those queries canned or are they ad hoc? What you're trying to do is basically estimate, am I doing large row scans? Do I have to scan the entire database? Or do my users just really care mainly about like the last week's worth of data or the last 3 months worth of data? So even though your data warehouse might be 5, 10, 20, 100 terabytes, you might be only scanning or dealing with a very small percentage of that. So as an analyst in this room, when you try to figure out how big a pizza do you need to do the job, look at your user workload profile. Understand how many of your users are doing simple queries, medium queries, complex queries. Map them out. One of the things you'll also notice, if you do this analysis and understand what your users are doing today, your analysis and your study is going to change tomorrow. And the reason why is most of the time, you're going to find that the majority of users are doing very simple queries right up top. A relatively small amount of medium and hardly any complex queries. As your users become more and more familiar with the database, the structures of the database, how to use the machine, what's going to happen is that the number of simple queries is going to go down, and the number of medium and complex queries is going to go up. So over time, over the first 6 months or a year, you're going to find that your workloads start to shift. And therefore, just bear that in mind. So don't be surprised if you see the resource utilization start to spike higher, even though your user population stayed the same. And that's because your workload mix actually shifted based upon your mix of simple, medium, complex queries. Other things you may want to think about when you're sizing a machine. Think about how compressible is your data. For example, right now on the PDW data warehouse, if you're using column store, we're assuming that you get about a 5x compression factor, 5 times compression. Real world, you're probably going to see more like 7 compression, maybe 10, but unlikely. Probably 7x compression is a reasonable number. We did all our math with 5x because we wanted to be conservative, just to keep it in the back of your mind. So you may want to find out how compressible is your data. Look at the cardinality distribution. What about your batch window? How long is your batch window? Can you load the appropriate number of rows within your overnight batch window? Do you want to do trickle updates? Maybe there's too much data to load. You may want to load data in a trickle fashion. These are all kinds of information you should think about as you're doing it. So in a nutshell, the bottom line is that different kinds of workloads, whether it be reporting, exports, maybe to, let's say, to a SaaS or to a vertical platform to do advanced analytics, OLAP queries, all these workloads are going to put different kinds of demands on the hardware. I/O throughput, network throughput, and those are different kinds of things you have to look at when you're doing this kind of analysis. And I could talk for a week about each of these subjects, how to model that. Are there any questions about that? Pretty straightforward? Okay. We're going to talk a little right now about the infrastructure and the architecture. So now we understand the users, what big data is, what the users are, and what their workload profile is. How do you go about architecting these things? What is a good 50,000-foot or 100,000-foot point of view about how to architect this? Well, on the left-hand portion of the slide, you're going to see you have your OLTP systems, your CRM, order, entry, finance, so forth and so on. I should have made unstructured data a lot bigger than what it is. But then again, most of the data that people are working with today is really structured. The unstructured data, all that Hadoop stuff, the semi-structured data, yeah, there's not as much of it going on in the industry as we told by the survey of this room. There's really very few people out of here working with unstructured and Hadoop data. The middle, on the right here, over here, these are your end users. Those are your executive dashboards. Those are your advanced analytics. Those are your reports. What we're going to be spending all of our time talking about is this middle tier, where you have your ODS, operational data store. That's optional. You may or may not have that. Some customers do, some don't. And then you have your data warehouse or your data mart in the middle. In case you don't know the terminology, I'll introduce you to another term. Operational data store and data warehouse or data mart, they're two different things. Operational data store is typically used in these architectures to support your day-to-day or week-to-week operations. The main difference between an operational data store and a data warehouse is primarily time. Operational data stores may have information, let's say for the last couple of days, couple of weeks, maybe up to 6 months, a year tops. The data warehouse, on the other hand, that has data over the last year, 2 years, 5 years, 10 years, or even longer. So warehouses track information over very long periods of time. Operational data stores for a relatively short period of time. Example, Deutsche Telekom. They have to keep track of all of the call detail records for 6 months. That way, if a customer calls up and says, I didn't make this phone call 4 months ago at this time, they can look it up and find out what's going on. That's an operational data store because it supports operations for a relatively short period of time, 6 months, a year, so forth and so on. That data that gets rolled off or simultaneously loaded into the data warehouse so they could do more business-like analysis on it. This middle tier, that's where you would have PDW or Fast Track. Fast Track scales, let's say, anywhere from about 5 terabytes up to about 95 terabytes. It is a scale-up architecture. I mean, yes, you could add disk drive, so forth and so on, but if you run out of CPU horsepower and memory, then you'd have to scale up and replace let's say, the servers themselves in order to scale up that environment. On the other hand, PDW, the parallel data warehouse, is a scale-out architecture. So if you run out of juice, you don't have to throw out your old hardware or upgrade it with a forklift. What you could do is you could basically just add hardware and add in smaller increments. So that's the main difference between the two. I jumped ahead of myself. So here we have the fast track, and here we have PDW, and it talks about the difference in terms of scalability. So the fast track is scaled up to 95 terabytes, as I said, and the PDW to over 6 petabytes. A couple of other buzzwords in terms of architecture you should be aware of. We talked about the operational data store. We talked about the data warehouse, or the mart in the middle. Frequently, what people do is in these architectures is that they front end the data warehouse, the enterprise data warehouse, with these things called data marts. These data marts could be roll-up in nature. Roll-up meaning relational database, relational online analytical processing, typically SQL Server. Most of these data marts are a subset of the data warehouse. That subset might be a subset of time. More frequently than not, it's more of a subset based upon business function. So you might have one organization in your company that just cares about a certain type of data. The marketing folks might have their own data mart, and the engineering folks might have their own, and the sales guys may have their own, and the factory floor might have their own. And they basically do their own extracts from the enterprise data warehouse in these various data marts so they can do queries. Similar vein for OLAP cubes. OLAP cubes are kind of a data mart. The main difference is their implementation. A roll-up is SQL Server, relational database. OLAP cubes uses Microsoft Analysis Services, which is more memory resident and memory bound, and tends to be very, very fast response time because everything is memory resident. Then on the bottom, we might have these other extracts where we have our third-party data mining analytics or in-database analytics. So this might be SAS, Vertica, so forth and so on, if you want to do in-database complex analytics. So far we talked about the transaction processing and the unstructured data. We talked about the users. We talked about the middle tier, which is the data warehouse, the operational data store, and the data marts, as well as the advanced analytics. The last thing I just wanted to touch upon is, well, how does the data get from the OLTP machine into this warehouse? And that has to do with the ETL tier, or sometimes people do ELT per se. And so it's either extract, transformation, and load, or extract, load, transform. Depending upon how you do it. And again, I could talk about those issues for a while. I can't do it under the time constraints. What other people do is they also use Hadoop. They may take Hadoop with the unstructured data and the semi-structured data, put it into Hadoop, and now Hadoop takes it, massages it, and loads it into the data warehouse itself, into a more structured form. So that way it's a lot easier for the end users to use these tools to access the data because now everything's structured. Okay, so it sort of begs the question, it's like, well, what is Hadoop? Well, Hadoop is basically designed in such a way it could use any type of data. The Hadoop has a file system called HDFS. It stands for Hadoop File System. And yes, it can handle structured data, whether it be relational or hierarchical. It handles unstructured, semi-structured data. Even though Hadoop could handle structured data, you try and run, let's say, a TPCH kind of query against it, like real queries for data analysis. With today's technology, it's not very good. It's slow, it's inefficient. So most of the time today, people are not going to be using Hive, which is another term you may have heard of, to access structured data on Hadoop, simply because there's performance issues involved with it. That may change a year, 2, 3, 4 years from now. As of today, most of the time, if you have structured data, you want to use a PDW or fast track or something of that nature. If you're using unstructured or semi-structured data, then you can use Hadoop to access it. What Hadoop does is they use something called MapReduce functionality, which you may have heard of before. What MapReduce does, it actually parses and indexes the data types, and it can manage basically any kind of information you got. It'll look at image data, it'll look at files, documents, anything. It can really look at anything. It really makes absolutely no difference. When you're dealing with Hadoop, one of the things you're going to find is, number one, it's non-trivial. If you want to learn MapReduce, you could do that. Those guys get paid big bucks. You know, it's a non-trivial exercise to use MapReduce, and then you could analyze the data directly using that kind of functionality. What people do more often than not today is they take the Hadoop data and they move it into the structured environment that I told you before, such as PDW or Fast Track, and now they could query it directly. And if they need to access the unstructured data, they could do that directly with Hadoop, but that doesn't happen as often. Now, one of the things that Microsoft has done relatively recently with PDW is they've come up with a product called Polybase, or a feature called Polybase. What Polybase does, they said, you know, MapReduce is kind of difficult for most programs to understand. There's not a lot of expertise in the field regarding MapReduce. Wouldn't it be nice if I could actually have a user over here doing a SQL query? That SQL query will go into the parallel data warehouse. It could hit the PDW database if necessary, but if it also needs data of Hadoop, it could get that as well. So what happens on the PDW environment using Polybase, you could actually use a query, You could join Hadoop tables with relational tables using standard SQL select statements, and it knows how to get data from one machine into the other and present the results to the user. So now what Microsoft has done is they come up with a very nice way to integrate Hadoop with a SQL Server environment. And as far as the end user is concerned, it's transparent to him. How is that accomplished? It's accomplished by using a couple of different technologies. One has been something called Hadoop connectors. The Hadoop connectors allow the PDW machine to physically connect the Hadoop environment. In addition to that, Polybase allows us to have external tables. So now the PDW appliance could create external tables on the machine. You could also join tables on the fly. So you could join tables using these external tables and the HDFS bridge to go back and forth. You could also parallel import tables. When I say parallel, today I think it's called Flume, if my memory is correct. You could actually take data today using industry standard software and pull data from HDFS into PDW into any other relational format. It is a single-threaded, slow process. What we've done with Polybase, or what Microsoft has done with Polybase, is they've actually do it in parallel. So in the parallel data warehouse appliance, you have multiple copies of SQL Server and multiple servers doing the same thing. Wouldn't it be nice if you get all those servers to pull data simultaneously into the parallel data warehouse, so things work a lot faster. Same thing on the export. If you decide the data and push it out from PDW into the data warehouse, you could do so as well. So it's a two-way kind of communication. Bottom line, with Polyserve, you get Polybase, you get some very nice features. In this particular case, it's showing an example where Microsoft Excel, and on the same slide, same report, we both have Hadoop data and structured data generated using SQL queries because the software does all the work for you and puts it together. Come on, slide. There we go. Other features I wanted to talk to you about that's available with PDW, with the Parallel Data Warehouse. In SQL Server 2012, which is what the Parallel Data Warehouse supports, we are running SQL Server 2012. There's a feature called xVelocity. xVelocity, in a nutshell, means column store database. So as you know today, most of you are familiar with when you take data and you put it into a database, you take the row and it gets put into a block and it compresses the block and all the data. And if you want to retrieve that, you have to read the block and then you basically extract all the rows and you can read everything a row at a time. What happens now, if you choose to do so, you can still use PDW in a row store if you want to do that. Not recommended. Most of the time, you're going to find out you're going to get a lot better performance using column store technology, aka xVelocity. So if you're using column store technology, what that'll allow you to do is most of the time, if you look at a row, when an end user submits a query, that row might have 10, 15, 20, 30, 50 columns inside of it. Do you think most of those queries are going to grab all 50 columns? Probably not. Most of those queries are probably going to get 2, 3, 4, 5 columns, if that. So why would you want to grab the entire row of data and the entire block when you only need a very small handful of rows? Wouldn't it make more sense to take that row and instead of storing it one row at a time, store it in a column of fashion? So that way, if most of your users go after the customer column or the products column, now you can get that data much more efficiently. In addition to that, you get better compression. Why is that? Let's say, for example, you have a column called products. If you, let's say a store sells millions and millions of products, you'd have a line item for every sale that took place. However, the store might only have, 50,000 individual products they sell, or 100,000. You compress it a lot more. How about if one of these columns is sex? Male, female. If you're in California, it might be 5 of them. Who knows? But in either case, the number of columns that you have to store is really just one. Only one column with a very small amount of information. So column store not only gives you greater compression, it'll give you better performance. It'll also utilize memory more efficiently, and you get better I/O throughput because everything's compressed better. So you have to read less blocks. So no matter how you slice it, you're going to find out that a column store will give you better performance. And there's one of the primary reasons why PDW version 2 gives you significantly better performance, like 50 to 100 times the performance of version 1. One other feature, the PDW version of the column store xVelocity allows you to update or do trickle loading or trickle updates of that. SQL Server 2012 does not support it yet. PDW does. So if you want to take your column store and if you want it to be updatable, you could do that in PDW, but you can't do that in SQL Server 2012 as of yet. The other thing you should be aware of is that, is my time right? Okay. is has to do with the scalability. The parallel data warehouse appliance is a scale-out architecture, as mentioned to you before, as opposed to scale up. In terms of what kind of performance we get, this was version 1. It's a little bit older slide. We've only been shipping version 2 since May. So it's only been, about a month, 6 weeks, something of that nature, not very long. But in terms of version 1, you're going to find out that versus SQL Server, that customers were seeing over 100 times performance improvement. And with version 2, we're seeing like 50x faster, somewhere in that. And that's because of X velocity, so forth and so on. So the parallel environment gives people significantly better performance. Are there any questions? Because I'm going to switch gears and actually talk about the PDW appliance itself. Okay? Okay. So we're going to dig deeper and start talking about the hardware. Okay. There's a picture of the PDW appliance. As I said a million times before, it is scalable. It's a scale-out architecture. The buzzword in the industry is that it's a massively parallel, loosely coupled, shared nothing architecture. Massively parallel is obvious. Loosely coupled and shared nothing basically means that there's no shared components, no shared memory. There's other companies out there that compete with this product that do have shared storage and things of that nature. Even though it looks like it's massively parallel, it's really not, because the shared storage becomes a bottleneck. That's not the case with PDW. Other thing you may want to be aware of, it says high performance. However, one of the things that's interesting is that if you look at any data warehousing application, what you care about is throughput. You don't care about IOPS. If you're doing OLTP or transaction processing, each individual transaction is pretty small. You want to make sure that you do as many small IOs as fast as possible. So IOPS are extremely important. When you're doing data warehousing, you're probably going to be doing a lot of table scans. And you want to scan as much data as you can as fast as possible into the box. So the name of the game with data warehousing is throughput. How many gigabytes per second, how many terabytes a second can I actually pump through the I/O subsystem here? And that's what really measures the performance of the machine to make sure your users get good response time. Obviously, the PDW is good price performance. We'll talk about that also. Availability, we'll talk about how that works. And support's a very interesting model. I'll touch upon this, but I'll give you a preview. The support model is basically Microsoft. You have one phone call to make. If anything breaks on this appliance, whether it be hardware or software, you call Microsoft. Microsoft looks at it and says, it's a software problem. I'll take care of it. It's a hardware problem. Microsoft will call HP and basically issue the trouble ticket report. So you don't have to look at it and say, is it a hardware problem? Is it a software problem? I don't know. You don't have to figure that out. You make one call to Microsoft, and Microsoft will do all the pointing for you. This is version 2 of the appliance that I mentioned to you before. Version 1 of the appliance actually consisted of 2 racks. Anybody here version 1 of EDW used to be called? No version 1s? Okay, I could save a lot of time then. Basically, version 1 was a 2-rack solution. Version 2 could fit in a single rack, in a nutshell. And the reason why is that we've consolidated some of the hardware, and we've also virtualized everything, in a nutshell. So since there's no version 1s, I guess go really quick on that. So how does PDW really work? One of the things you could start with is the very smallest unit. And the very smallest unit is called a base scale unit. That base scale unit consists of 2 servers. Those servers have a name. The name is called HSA01 and HSA02. There's 2 servers there. They're DL360s, which we'll talk about in a second. On the bottom over here, we have a D6000. Those are SAS disks, just a bunch of disks. This particular array has 70 disk drives in it. 35 of them go to the HSA1, and 35 of them go to HSA2. And of course, each one of these DL360s have internal storage as well. So that's, in a nutshell, what the base scale unit is. Here are more details on it. If you go to the HP website, you can look at the quick specs. And if you look at the quick specs, it'll give you all the specs of the speeds of the machines. Each one of these servers has 8 cores in it. I told you about the 70 spindles. And you have a choice when you order this, whether you want 1 terabyte, 2 terabyte, or 3 terabyte disks. So you're going to get the 70 spindles no matter how you cut it, but you have to make a decision what the density of those disks are, depending upon how much space you actually want in the machine. Okay. Now, when you scale this, unlike Fast Track, when you scale it, you don't have to basically replace the server and the memory. What you can do here is you simply have to add scale units. And when you scale units, here's your base. You say, oh, I want twice as much horsepower. Well, I add another scale unit. I want more horsepower. You keep on growing up and up and up. So in this particular case, we have scale units that go from 1, 2, 3, 4, 5, 6, 7, 8. And the numbering schemes goes up from the bottom. That's how it grows. It grows up from the bottom. Other thing you should be aware of, which I think is on the next slide over here, is the fact that each one of these scale units actually is running a copy of SQL Server. So in reality, in this particular case, we have 8 servers. There's 8 copies of SQL Server, 8 instances actually running simultaneously. As far as your operations staff is concerned, as far as your users are concerned, you don't know that. Your DBAs simply say, create database, create table. You don't have to worry about the fact that there's, in this example, 8 copies of SQL Server. The PDW software in the background actually does create 8 databases, 8 tables, sets of tables for you, but you don't worry about that. You don't have to worry about file groups, any of that other stuff. That's all set up and automated for you. We've dramatically simplified the operation of the machine by hiding all that work, because trying to manage all these up to 64 copies of SQL Server is going to be a nightmare. So we simplify that and basically eliminate it for you. Yes? That's a I'm a techie. I don't think, it's part of the licensing when you license it. And especially if you have a corporate license for SQL Server, then it's really not as much of an issue. So I'm not a Microsoft guy, so I don't deal with the pricing. I just don't know in terms of licensing how it works. I do know that the PDW software is licensed separately from the SQL Server licenses. So if you have a corporate license, it's going to end up being cheaper than if you don't have a corporate license, so forth and so on. Other thing you should be aware of is when we run these things, in each one of these servers, not only do we have a copy of SQL Server, we have something called a compute node. A compute node is PDW terminology, which is why I'm introducing it to you right now. What a compute node does, or a compute virtual machine rather, it used to be a node when it was actually a server, that's where you actually store the data. This is where the query processing actually takes place. That's what a SQL query actually executes. And if you're doing a join, bear in mind that some of the data may be on this server over here, other data may be over here. So if you're doing join, some data may have to go back and forth using InfiniBand between those nodes. If the data goes back and forth, basically the data movement service, the EMS service, handles all that traffic going back and forth using InfiniBand. So it's extremely fast. It uses FDR InfiniBand. So let's talk about how the query goes through the machine. Here's our end user queries using whatever tool that they want to use. That query goes into another server, which I didn't tell you about yet. That other server is called HSTO1. That's, again, a DL360 sitting on top. This runs the control virtual machine. Query goes into this control machine. It gets compiled. Once the query gets compiled, it says, oh, I want to execute this query in parallel because I want to get very good performance. So what it does is it takes a piece of the query and ships it off to each one of these servers and runs it in parallel. So therefore, you're going to find out that we actually have 128 cores working in parallel to service your query, which is one of the reasons why PDW is so fast. So it's not a single-threaded operation. You're getting 128 cores all working in parallel, and then after it executes the query, it sends the result set back to the control node, and then the control node then sends the result back to the end user. In a nutshell, that's how PDW works. Yes? Yeah? Say again? Mm-hmm. The compute node is where in this implementation of it, what happens is that, let's go back one slide over here. The HSA terminology, this terminology over here, that's the physical hardware itself. If I go back 2 slides, come on. Okay. Doesn't like to go back. Go back 2 slides. Let's try again. There we go. Okay. You have these things called compute nodes in here also. This doesn't show. That is correct. You have the base unit, you have 2 compute nodes. So there would be a control node up here, which is not drawn on this particular slide. The query goes into a control node, and if you just had these 2 units, it would compile the query. It says, I want to run in both of these servers simultaneously. It sends the query to the compute nodes. The compute node then talks to SQL Server directly. So the compute node is basically a virtual machine, is what it is. And then it talks to its copy of SQL Server, and then sends the result set back. HSA is simply a name of the hardware. HSA is simply the name of the hardware. So if you were to look at the physical hardware itself, that's an HSA. But the software, the PDW software itself, talks about things like compute node 1, compute node 2, compute node 3, compute node 4. And there's a one-to-one mapping. So compute node 1 will always map to HSA 1, which is the physical hardware. Compute node 2 will always match to HSA 2, which is the physical hardware, which is the virtual machines. No, it cannot be changed. No, you don't want to do that. When we configure this machine, we want to make sure that compute node 1 is aligned with HSA number 1. Now, if there's a failure, it's a whole other situation.
But that means that when we bought the appliance, you already had a compute node and then process.
Yes, when you buy this, we turn the keys over to you and say, Mr. Customer, here's the PDW. When you look at that machine, you will see compute node 1 is running as a virtual machine, and it's running on HSA 1. Compute node 2 is a virtual machine running on HSA 2. That's what you will see.
So with these two units, the two compute nodes, the base units, basically, the high availability.
Wait, we'll get to availability. We're not there yet. Okay. Other couple of things I want to mention to you. On top, I told you about this HST node. We talked about the control virtual machine. That's who does the compiles and so forth and so on. In addition, on this physical server in HST01, there's the virtual machine, which we talked about, called the control virtual machine or the control node. There's also a management virtual machine. The management virtual machine holds the Active Directory, basically handles software packages. It does all the management kinds of things. It really doesn't burn a lot of CPU cycles or a lot of resources. So both the key control node and the, did I make a mistake? That's a mistake. That's a typo. That should say control 01. That's a typo. I just noticed that. That should say control 01 and mad 01 run on this server over here. I should fix that. Other thing now we're talking about availability, so the segue is pretty good here. Okay. In addition to all of the, in addition to all the nodes that we talked about over here, we have HSA01 that has those servers on it. There's another server you have to buy with it. So the smallest configuration that you could buy has the base scale unit, which is 2 servers. You will also get HST01. You're going to get all the switches, which we didn't really talk about much, all the InfiniBand switches and Ethernet switches. And then you're also going to get HST02. HST02 is a passive server. It's sitting there backup, not really doing anything. Okay? We're going to talk about how it works in a minute. We're not there yet, but just bear in mind that's a passive server. If you want, you could buy another passive server. So you get HST02 and HST03. So if you're buying a single rack, you'll get HST03 also, if you choose to do so. If you, remember I said this scales out? You can scale out to 2, 3, 4, 5, 6, 7 racks. If you scale to 2 racks, HP says this HST03, that passive server, is no longer optional. You have to buy it. And each additional rack has to have at least one other passive server in it. Okay, that's the rules of the game. That's what when you read the text, that's what this text says, basically. It says, when you're buying a single rack, you can have HST01, which runs control and management. HST02 is a passive server in case there's a failure. If you want HST03, it's optional. If you go to another rack, no more option. You have to get HST03, and every additional rack has to have one and only one other server. That's what this text says. What do those passive servers look like? They look the same as the active servers. They're basically DL360s, and those are the specs for it. They're identical. Okay. I mentioned before that we use switches. It comes with the FDR InfiniBand switches, Ethernet switches. There's 2 of them for high availability and full tolerance. I think we talked about everything else on this slide. There's what it would look like in the rack. So if you were to buy it today, there's 8 nodes. So we have 2, 4, 6, 8 nodes. You have the base scale unit, 3 actives, and I think we talked about everything here. Buzzwords you should be aware of. Sometimes people will call the base scale unit, they'll call it a quarter rack. It's a problem for the near term. It makes sense as a quarter rack because you go to 8, so 2 is a quarter of 8, so that makes sense. I suggest that you don't get used to that terminology, and I'll tell you why in a second. It makes a lot more sense to say we have 2 active units plus 2 passive units. In this slide, we have 8 active servers and 2 passive, so we call an 8 plus 2. or full rack. The reason why it's confusing is on my next slide, because in the near future, hopefully by the end of the summer, Microsoft is going to be able to do some quality assurance on PDW version 2.1. What happened was, there's enough space. If you go back to the previous slide, see this space over here? That's not being used. It's kind of silly. We have room in the rack. So wouldn't it be nice if we could put a fifth scale unit in there? We can. It's just that Microsoft didn't have time to do QA on it and quality service on it. So you could do an add scale unit functionality in version EDW 2.1 and be able to do that. There's another reason why we didn't do this. It has to do with the weight. If we added this fifth scale unit, that pushed up to about 2,000 pounds, which was the borderline threshold of what HP could actually ship, what the trucking company actually move. So we're working on the weight issue. But the bottom line is, in the very near issue, you will be able to have a fifth scale unit per rack. So remember I said a quarter rack is kind of silly terminology? Well, what's a quarter of 10? It doesn't make sense. So you're much better off saying, I have a 2 by 2, I have a 2 by 3, I have a 10 by 2 here. That makes a lot more sense. Okay? As I said before, how am I doing time-wise? Okay. As I said before, you could scale out up to 7 racks in this particular case. You start at about 76 terabytes and scale to about 6 petabytes. Other thing you should be aware of, when you're buying Fast Track, if you're buying a Fast Track scale-up solution, this is what gets delivered to your facilities. You order parts, you put it together yourself. If you don't want to do that, Fast Track also offers you something called factory direct. I forgot the name of it. It just popped out of my head. I just popped that in. HP will build it in the factory for you. I forgot the name of it. But HP will fill the factory for you. So this way it could show up like it was an appliance, basically. So we'll do the building for you. On the other hand, as far as the parallel data warehouse is concerned, in this particular case, what happens is you will always buy an appliance. You don't build anything. What ships from the factory is what you see here. Everything's pre-racked, pre-cabled. The software is pre-installed. Once it shows up on your data center floor, we plug it in. We hook it up to your network. You tell us the TCP/IP addresses that you want to use. And we say, here, Mr. Customer, here are the keys. You're ready to create database, create tables, start loading stuff, because the machine's all pre-configured and ready to go. So it's a hell of a lot faster for you and a lot easier for you. And this is an example of a 7-rack system. In terms of what's the limit, you could grow this up to 64 total nodes. So if you want to know how big you could grow this, Windows Server 2012, the clusters, have a limit of 64 nodes. That's the limit. How do you count it? You would count each active node and the passive node. So if you would add each one up, you have 2, 4, 6, 8, 10, plus you would have 3 over here in this configuration. So you would have 13 servers. And if you do your math, you end up with 64 servers as your max. In terms of space, here's the math for the space. We're assuming a 5-to-1 compression ratio. If you have 1 terabyte disk, you start at about 76 terabytes, and you could go up to about 2.1 petabytes. In the case of 2 terabyte disks, 151, and this scales to about 4.2 petabytes. And the 3 terabyte disk, there's where we get the 6.3 petabytes that we could scale to. That's how the number was derived. And that's assuming a 5-to-1 compression ratio. If your compression ratios are 7-to-1, you could probably store more, but that's not what we're assuming for the model. Okay, let's dig a little bit deeper into talking about the availability, in terms of fault tolerance and availability. How's that really work? Okay. Remember before I told, how much more time do I have? 26 minutes. Okay. Before I talk to you about, we have the various servers over here. Has HST01, that has your control and management virtual machines on it. HST02 is sitting there doing nothing. It's a passive server. Then you have your 2 compute nodes that are running those, the compute nodes, CMP01, CMP02, and is also running a copy of SQL Server down here. Here's those D6000s with the arrays, connected via SAS storage. Everything's connected with a Ethernet network as well as dual InfiniBand networks. So everything's dual over there. Traffic's going back and forth. So how does it work so far? An end-user query goes into the top node, HST01, normal operation. The control node compiles the query. Let's say in a 2-node scenario, sends the query down to these 2 nodes. He executes SQL Server in parallel. He executes it, hits all the disks, goes back over here, sends the user here, goes to the user. Now there's a failure. One of these compute nodes fails. What happens? Well, what happens is you'll notice the connectivity. This D6000, all of these disk drives, the mirror disks, all of these disk drives, could be accessed by this node over here. In this particular case, what happens is HSTO2 says, there's a failure. I have to take over. So HSTO2 now takes over, and he actually starts running. Which compute node was failing over there? This is the second compute. This is the first compute node. It says node number 1. So you would take compute node number 1, the virtual machine. Compute node number 1, virtual machine, would take over here, and this in the HSTO2. SQL Server would also execute for over here, and then it would start doing all of its I/O through the second node and hit the disk drives. So as far as the system is concerned, the end user still thinks that the machine is up and running, and still thinks that this node is actually running, but it's really running up here instead of down there. Now you may be saying to yourself, oh my God, what's going on here? I have a failure here. This node over here is doing all the I/O to this machine. A failure took place. Now instead of this server accessing its own disks, this server up here is going to do disk I/O through this server to access the same disks. Won't this become a bottleneck? I mean, that was my first reaction when I saw this. Well, what happened was Microsoft actually ran some tests on this particular environment, and one of the things they found out is that there's very little overhead on this machine. And the reason why is you're using RDMA access with InfiniBand. So when SQL Server is running up on this server over here, SQL Server has its own cache up here, has its own memory up here. So if you're getting cache hits, it's all happening on HSTO2. If he needs to do a disk I/O, the disk I/O goes directly using RDMA, direct memory access, down to node number 2. It doesn't really interfere with this machine because it actually does the I/O directly to disk, sends the result here, and goes up via InfiniBand. So the CPU cycles burnt and the memory resources burnt on this node are virtually non-existent. So even though the data is actually going through here and through the InfiniBand, you're not burning a lot of those CPU and memory resources on node number 2. So it actually works, yeah. Mm-hmm.
Why this compute node second take over? And the compute node second, to me, I thought it was the failover. I mean, I thought it was the standby for the compute node 1.
Good question. This second passive node, HSTO2, can act as a failover node for any failure in the entire cluster. So if you have another rack or a third rack, HSTO2 can take over for any other server that failed in any other rack. As you scale out racks, any server that's sitting there as a passive server can act as a backup server or passive server for any failure in the entire cluster. So that's what it is. So if this node would have failed, he would take over. If this node would have failed, he would still take over. And if I had HSTO3 and an extra passive server there, either one of them could be used. And of course, this all happens automatically.
So if the HSTO2 takes over from the application layer, anything else they need to do?
In this particular scenario, because we only have a quarter rack and only one passive server, if there's a second failure, the machine will be down. Because there's nowhere else for anything to migrate. Now, if you had HSTO3, and if you have an extra failure, now you could fail over to HSTO3, and that would give you that extra little fault tolerance. But be aware, there's a problem. In this particular case, let's say you had HSTO3, and if this were to fail over here, you got a problem, because now you can't get to any of your disks. Problem, you're down. But if you have HSTO3, and if this failed, and if node 1 failed, now he could fail over here, and you're still okay. So depending upon what multiple points of failure take place, you may or may not be able to survive them. So in general, they say it'll sustain a single point of failure. It might sustain 2 points of failure, depending upon what they are. If they're both next to each other like this, then it's going to be a problem, both next to each other, because you can't get to the disk. Okay, any other questions? Okay. This just has a graphic of what I just talked about verbally. Okay. This slide, nobody here has EDW version 1. I'll just say very briefly that if you did have EDW version 1, one of the things that HP and Microsoft did was we wanted to make sure that you didn't have to migrate the hardware. You didn't have to throw out your old hardware. We wanted to make sure you maintain your investment, and so therefore PDW version 2 software would also run on the version 1 hardware architecture, because version 1 hardware actually used SAN storage and a whole bunch of other different configurations. So let it be said that HP and Microsoft wanted to make sure that you maintain your investment. It's a non-issue at this point. In case somebody's listening to this recording that happens to have it, I should probably say what this slide actually means, and that's the fact that there might be hardware changes. If you're running EDW version 1, you might have to upgrade the InfiniBand. If you were running DDR or QDR InfiniBand, you have to upgrade the FDR. You have to upgrade the firmware. The firmware and the drivers would have to be updated. HP has a utility suite to automate that process to make it easier. And then Microsoft will come in and rebuild it using the PDW software on it, version 2. One thing I wanted to point out is that I hate to mention that other competitor that we have, that 4-letter vendor that also sells PDW. But in either case, HP, one of the things that we do to bring value to this, other than having the HP hardware, we also have software that's available that you cannot get in other vendors' equipment. We have something called the PDW Support Pack, Utility Pack, and there's a whole bunch of utilities that make the operations a lot easier for you. Things that you might not think of until you actually start using the machine. For example, one of the things you may not think of is if you look at a PDW appliance, you could have over 2,000 components in that machine. All those components have your various servers, your various controllers, various devices, InfiniBand, Ethernet. All those things have firmware, drivers. You have to make sure all the firmware and drivers are kept in sync. If they're different, you have a problem. So therefore, one of the things that we've done is we wrote a utility that allows us to make sure that all your firmware and drivers are not only compatible with whatever PDW software you're running, but are also synchronized. So if you need to do a firmware upgrade, it will automate the firmware upgrade for you across your entire appliance and across all your servers. So it greatly simplifies your operations. So that's an HP only kind of a thing. Same thing with validating to make sure that everything is valid running on your machine, both the hardware and the software. Other thing that HP brings across to the table, things you wouldn't have thought of. What about serial numbers? Remember, there's over 2,000 parts here. There's a lot of controllers, a lot of switches, so forth and so on. Rather than taking, in the early days, I took my little magnifying glass and flashlight trying to read all the serial numbers off the back of the machines. That wasn't fun. So one of the guys in our lab tried to include on the script a report that basically gives you a listing of all your serial numbers on the machine. So this way, when Microsoft gets involved, I had a failure here, you know the serial number of the part, and it makes the whole troubleshooting report process a lot faster. Other thing that we have is we have a separate set of diagnostics. When you buy PDW from Microsoft, there's a set of diagnostics called PAV. And PAV is the Microsoft Diagnostic Utility. What we've done is we've gone beyond PAV. When you get the machine, things might get jostled, even in your own place. It'll check things for like loose cables. It'll check things to make sure, are we getting the right speeds out of the box? So it'll say, we expect that the InfiniBand or the disk drive should be running at a certain speed. It'll run speed and feed checks. Make sure all the cables are plugged in to the right ports and are not going to the wrong place. They're running at the correct speeds. Make sure that all devices are healthy and are functioning properly. So there are extra diagnostics that we give you that you will not get from other vendors out there. And the last thing, this isn't quite there yet. It was at EDW version 1, but in EDW version 2, I used it myself last week. But it's not available for you guys yet. It will be hopefully in the next couple of weeks. And let's update the passwords. Why is that important? When you buy PDW, Microsoft gives you software that has a screen, and it says, do you want to change your password? And you go in there, boom, and you change your password. Not rocket science. What you don't think about is that all your devices have passwords on them as well. Every switch, every controller also has administrative passwords associated with them. Today, on our equipment, or let's say other vendors' equipment, you go in there and manually have to change all those passwords to make sure they're all in sync. Otherwise, you may have a security problem. What we've done is we've written scripts to make sure that you change the password, and it'll change all the passwords in the appliance for you. Those things that you don't think about, the switches, so forth and so on. So those are just, and then there's another script coming in place to make it easier to change the IP addresses if you want to do that as well. I mentioned this slide to you earlier that Microsoft is a single phone call support, one throat to choke. Call Microsoft and they figure out whether it's a hardware or software problem, and they will call HP directly. Other thing you should be aware of is that this particular appliance is really just a data warehouse. Version 1 of the appliance came with a backup node, and it came with a landing zone. And the landing zone was able to run your ETL functionality on it if you chose to do so also. We've taken that out from version 2 of the product. And the reason it was taken out of the product is because every customer, almost every customer, had their own backup facilities. They were paying for backups that they didn't really care or needed about. Same thing with the ATL tier. Many times those customers already had, they were running integration services. They were running Informatica or some other vendor's ETL software on some other tier. They didn't need our landing zone. If they wanted to, they were buying it anyway. If we ripped it out, you could use your existing hardware to do backups, use your existing hardware for the landing zone and ETL tier. If you don't have that, HP also sells, as an option, you don't need to do it, but as an option, something called the Data Integration Platform. I personally think it's a poor choice in words. I'm not marketing. But the Data Integration Platform has been architected to not only run ETL software and act as a landing zone, but it could also perform backup operations as well. Now you say to yourself, why would I have the same hardware do both backup and loading functionality? Well, if you think about it, what are the odds that you're going to be loading data at the same time you're backing it up? Not very great. So you might as well use the same hardware for both. This way you're using the hardware all the time, or more efficiently. So that's the reason why we configured it for both kinds of operations. Other thing you may want to be aware of about ETL software and landing zone, version 2 is a little bit different. Version 1, you could have only had one landing zone to load data into the machine. Same thing for the backup. You only have one backup node. Version 2 of the PDW software, you could actually have multiple ETL tiers and multiple landing zones to load data into the warehouse in parallel simultaneously. So you're going to get much greater load speeds because you could load in parallel from multiple servers. Same thing for backup. You could back up to multiple servers simultaneously if you choose to do so, or back up maybe to a disaster recovery site. So what Microsoft and HP have done is we give you a lot more flexibility in terms of loading and in terms of backup capabilities. And of course, the rest of the slide just gives you the specs regarding this data integration platform. What about price performance? Any other questions so far about the architecture? Yeah, go ahead. No problem. We have time. I have another 12 minutes. Well, the compute node is what's associated. That's the node that does all the work with SQL Server. Yeah. So the minimum you could buy is 2 compute nodes.
Okay, but what I see this structure right now is, to me, each SSA has a one compute node.
That is correct. HSA is one compute node. I know. I was talking to you before. You were talking about having. I have to ask Microsoft about that. What her question is? She was in the booth earlier, and one of the things she wanted to do was she wanted to say, for the most part, we have multiple copies of SQL Server, but for all intents and purposes, it's as if you had a single logical instance of the database. And what they wanted to do is they wanted to have multiple instances on the PDW appliance. Apparently, somebody at Microsoft said that you could do that. I do not know. I had not heard of that. I'm going to have to ask Microsoft much this way that you did to find out if you could do that. Whether you're going to have 2 compute virtual machines on the same machine, talking to 2 copies of SQL Server instances. Excuse me. You may be able to do that. I just don't know. I have to ask Microsoft just like you. First time I heard that request. As far as price performance is concerned, any other questions, by the way? Okay. As far as price performance is concerned, if you analyze this in terms of like dollars per terabyte, we're extremely competitive, dollars per terabyte, compared to any other vendor out there on the marketplace. So it's a very, very cost-effective data warehouse kinds of solution. And if you read the small print here, it tells you how we calculated that. So the bottom line is, if you want to read this at your leisure when you look at the slides, is that the Microsoft HP PDW gives you the best dollars per terabyte compared to Oracle, IBM, Greenplum, so forth and so on. And those are the big boys on the block. I'm surprised they didn't put Teradata there. Other thing you should be aware of, I talked before as a summary, that it is scalable for about 70 terabytes up to about 6 petabytes. It is denser. It's about 2.5 times denser than version 1 of the appliance. In terms of price performance, the cost is about 35% less than version 1. You can actually get into this machine for about $300,000 for a quarter rack solution. That is for the hardware only. I'm not marketing, so I don't know what the software piece of the equation. From the hardware, This number was close to $1 million before. Now we're less than 300,000. So you get into PDW relatively cheaply. The scan rates are about 10 to 30% faster. However, you say to yourself, but didn't I say a few minutes ago that we're seeing like 50 to 100 times better performance, but our scan rates are only 10 to 30% faster? Well, the reason why is primarily because of some other software change that took place, primarily X velocity, that column store technology. So because of X velocity and column store technology, yeah, we're getting better scan rates, but we're getting much better performance. The moral of the story is that if you're trying to compare one vendor to another vendor in terms of performance, unfortunately it becomes a little bit more difficult. Because in the old days, we used to look at scan rates. Now, scan rates aren't quite as meaningful because when you're doing column store, you're getting a lot better performance out of it. You're getting much more bang for the buck. And of course, compression, we're getting significantly better compression in row store versus column store. And of course, HP has its own value-added utilities that you're not going to get from other vendors out there. And those are just some URLs. So we have about, I think, 8 minutes, 9 minutes. Anybody have any questions? Yes, no, maybe? Well, I think Microsoft is going to be distributing this slide deck at TechEd, for the TechEd slide deck. And I think they're doing recordings also, so you'll get that there as well. If you want to look on the websites, just go into Bing. I have to be Microsoft, correct. And if you do like, HP, Parallel Data Warehouse, quick specs, that'll give you the quick specs on it, a lot of low-level detail on it. You use these URLs here also. The quick specs will give you low-level detail as opposed to some marketing literature. So you'll get more meat in the quick specs. Anything else? Okay. I guess we got an extra 8 minutes or something, 7 or 8 minutes. Okay. Thank you so much. If you have any questions, I'll be in the HP booth downstairs. And I'm going to try, when I see the appropriate Microsoft people, I'm going to ask you a question about the multiple virtual machines. Yeah, hopefully.